Welcome to Lesson 128, Subtracting Mixed Numbers. Today's objectives: I will be able to subtract mixed numbers, and I will be able to subtract mixed numbers using regrouping. Alright, so the first thing that we always have to check when we're adding and subtracting fractions is whether or not the denominators are the same. In this case, my denominators are the same, so I can move on to the next step. Since I'm subtracting, I have to look at my fractions first, and I look at my numerators and I see that I have 1 minus 2. I know I can't do 1 minus 2. However, if I make this into a picture, I see that I have 4 minus 1. So since I have more here than I do here, this subtraction problem is possible. Okay. The only part that makes it difficult is the fraction, because here I have 1/3 and here I have 2/3. So what we're going to talk about is when we do have a problem like this, is how to regroup it and make it so that way we can actually solve this. And it's going to be odd because we're going to change this into a mixed number that also has an improper fraction. And the only reason we're doing that is to make it so that way we can solve the problem. Alright, so here you should have these pieces already cut out. I gave them to you in class the other day. And what I would like you to do is, before you do any taping or gluing or anything of that sort, I want you to follow along with what I'm doing. If you want to pause and go slower, that's fine. I just want you to have a visual and be able to see what is actually happening when we're regrouping. Now, regrouping is a lot like borrowing, except for when we borrow, when we subtract, we always make it so we add 10 to the next number. In this case, that's not going to work. Sometimes we might have to add 10, but more often than not, we're adding a different number. So in this case, my numerators, again, don't work. My denominators do, but my numerators don't, because I have 1 minus 3, and that's not going to work. I also need to check, though, if I do 4 minus 1, will that work? Since it will work, I know this problem is able to be solved. So what I'm going to do is I'm going to regroup and change what I have for whole numbers and what I have as a fraction. I don't want to change anything here, because if I change the second number, and we can line this up vertically so it would make a little bit more sense. So if I have 4 minus 1 and the 1/5 and the 3/5. If I change this down here, it's not going to make it any easier to solve. So I know every change is going to be made to my top number, or to the first number. In this case, I'm going to borrow 1 whole group from the 4, so that's going to leave me with 3 whole groups. Now remember, this mixed number tells me that I have 4 whole groups of 5 with 1 piece left over. So what I did was I'm borrowing from the whole group, and I'm changing that whole group into a fraction. So now instead of having 4 whole groups, I have 3 whole groups. And since I changed all these to fractions, I move them over to the fraction side. Right, so now I have 3 whole groups left over here. I know that 1 whole had to be 5/5. So now I'm adding those extra 5 pieces back to my numerator. So my problem actually becomes 3 minus 1 for the whole numbers, and 6/5 minus 3/5. Now this problem is possible to do, because I can do 6 minus 3, which is 3/5. And I can do 3 minus 1, which is 2. So my answer in this case would be 2 3/5. So what you're doing is you're taking this whole number and you're changing it into a fraction. Another way, or an easier way, to remember how much you're adding to the numerator, because again, this time it wasn't 10, it was 5. I know that I need 5 pieces to make a whole group. So if I borrow a whole group from here, I'm always going to add whatever my denominator is to my numerator, because that's how many pieces I would gain going from a whole group into a fraction. So this 4, this one whole that we borrowed, so one of them, changed to 5/5. And then because it became 5/5, we moved it over here. Right. So what you can do is you can paste this into your workbook. You can use tape. I would suggest tape. Glue would probably make this a little bit harder for you to turn the pages and make it very bubbly. If you don't have the utensils to do that at home, you can do that at school or on your own time when you have the materials that you need. We can change our mixed numbers to improper fractions to solve. However, that adds a lot of extra steps. So now we have to check the denominators. If the denominators aren't the same, we have to make like fractions. After we make like fractions, then we have to change both numbers to improper fractions, subtract, solve, and then change it back into a mixed number. I know regrouping can seem tricky. However, once you get the hang of it, it comes very easy. So I'm going to ask that all of us are using regrouping and not changing to a mixed number into an improper fraction. So in this case, again, always check your denominators first. I have 12 and 12, so I'm okay. And then check your numerators, 5 minus 7. Can I solve that the way it is? No, I can't. So the first thing I'm going to do, I'm going to line it up vertically. Makes it a little bit easier to see what I'm doing. We're more used to looking at subtraction problems this way than we are this way. So that would be my first suggestion, because here you can tell that it's not going to work just yet. The next thing I would do is I'm going to borrow from the 6, and that one whole is going to get added over here. So now I'm adding the one that I borrowed, so that's the one whole that I borrowed, and it changed to a fraction. I'm going to add that to the fraction that I already had. So I'm adding 12/12 to 5/12, and now I get 5 and 17/12 minus 2 and 7/12. Now remember, this is okay because this means the same thing as this, because a fraction tells you how many pieces you have. Every single time you work with a fraction, it's telling you how many pieces you have, how many groups you've put them in, and how many are in that group. So in this case, if you look at this problem, we have 6 times 12, which is 72, plus 5 is 77. Here, if you do 5 times 12, you get 60, plus 17 is 77. So they are giving you the same amount of pieces, it's just dressed up a different way. Now I can solve those. So 17 minus 7 is 10, and I'm going to write the answer over here. 10/12. 5 minus 2 is 3. As always, we like to put our answer in simplest form. The 3 does not change. When we put numbers in simplest form, it's only the fraction that changes. And in this case, I can divide them both by 2 and get 3 and 5/6. Alright, I'm going to help you with the first one, and then I would like you to try the next two on your own. All we're doing right now is regrouping the numbers. So what we're doing is we're pretending like we have a math problem that's not going to work, and we're just practicing regrouping. So I'm going to borrow from the 5, and it becomes a 4. Now I'm going to add 8 to my numerator because it's 8/8 that I'm adding. So I'm fine if you're comfortable with saying, okay, I just add my denominator to my numerator. If seeing the 8/8 helps you, that's fine as well. So now I know that I have 4 whole groups, I have 11 pieces, and I put 8 in each group. So when I regroup this, I should have gotten 4 and 11/8. So when you regroup, you should end up with a mixed number that has an improper fraction. So I'd like you to go ahead and solve the next two on your own. When you come back, we'll go over your answers. All right, so 14. This one's tricky. I still borrow from the 14 and it becomes a 13. But now, let's say my problem was 14 minus 3 and 1/3. Because this means that I have 14 groups, since I don't have a fraction with it, I can make my denominator whatever I want it to be. My thought would be if you're working with a problem that has thirds in the denominator, I would use thirds in the denominator. So in this case, this would be 13 and 3/3. You have to look at 14 as though it were 14 and 0/3 or 14 and 0/5. Whatever number you're working with or whatever denominator you're working with, you want to keep that denominator the same. Otherwise, you have to go through the process of creating equivalent fractions. Right, so in this case, I can also say that it's 13 and 1/1, or 2/2, 3/3, 4/4, whatever it is. If you don't have a fraction with this in the first case, then you should always have the same number on top as you do on bottom for your new fraction. 6 and 2/3, I borrow from the 6, it becomes 5. I add 3 to my numerator, and it becomes 5 and 5/3. So now let's try applying this to actual problems. So in this case, we always have to check first whether or not we can do the subtraction problems. Because I know that you know how to subtract, the majority of the problems that I'm giving you in this video use regrouping. So the first thing I check is my denominators. Are they the same? Yes, they are. So now I have to look and see, can I do 4 minus 5? Well, I'm going to put this vertically because it makes a little more sense to me if I write it that way. I can't do 4 minus 5, so I know I have to borrow from the 7 and it becomes a 6. Since I know 6 is my denominator, I'm going to add that to my numerator. So my new problem becomes 6. I'm sorry, that should be a 6. And 10/6 minus, now I don't do anything to that bottom number. I leave that number the way it is. Now I get 10 minus 5 is 5. My denominator stays the same. 6 minus 2 is 4. There's no simplification that I can do, so my answer is 4 and 5/6. I'd like you to try the next two problems on your own. When you come back, we'll go over your answers. All right, so 17 in this case, I have 17 and 0. Since I'm working with thirds, I'm going to put thirds. And then I would subtract 2 and 2/3. Well, since I have none, I can't take 2 away from that, so I know I have to borrow. My denominators work, my numerators don't. So I borrow from the 17 and it becomes a 16. I add 3, okay, because that's how many pieces I gained from changing this from a whole group to fraction. So my new problem becomes 16 and 3/3 minus 2 and 2/3. 3 minus 2 is 1. 16 minus 2 is 14. There's no simplification, so my answer is 14 and 1/3. Eight and 1/4 minus 5 and 2/3. First of all, my denominators don't work. So the first thing I had to do is I had to find the LCM. In this case, it was 12. So 1/4 had to change to 3/12. And 2/3 changed to 8/12. Now this is where it's really important to make sure to put the correct fraction back with the correct whole number. So in this case, since 1/4 went with the 8, that means that 3/12 has to go with the 8. And since 2/3 went with the 5, That means 8/12 has to go with the 5. I can't do 3 minus 8, so I borrow 1 from the 8, and it becomes a 7. I add 12 to my numerator, so this is 7 and 15/12 minus 5 and 8/12. Now I can do my subtraction problem, so I do 15 minus 8, which is 7, and it's still 12ths as the denominator, because I always keep that denominator the same. 7 minus 5 is 2. No simplification, so my answer is 2 and 7/12. So what I want you to do here is I always want you to think of this as maybe kind of pizzas. So if you looked at this as I had 17 pizzas and we ate 2 2/3 of them. So if you took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if we ate 2 whole pizzas, that means we ate this one, so that one's gone. I'm down to 16. Now I'm down to 15 because we ate 2 whole pizzas. Now out of this pizza, we didn't eat the whole thing, but we ate 2/3 of it. So this one's gone, and this one's gone. Now all I have left is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 whole pizzas, and 1/3 of a pizza, that little portion right there. All right, so when you're struggling, if you need to, go ahead and grab a separate sheet of paper and draw a picture. I know this is a difficult concept, so I just want you to take your time and understand regrouping and how and why it works. So that way you know when you have to actually use it in a problem, you'll know that you're using it correctly. All right, so the last thing I would like you to do, you have these problems in your notes, and they might be a little bit scattered in there. So here are your notes. I gave you these 3 down here, and we didn't try them yet. These 3 I want you to try on your own, as well as these bottom 3 subtraction problems. Okay, so you're trying these 3 problems on your own. These you're just regrouping. So just show me what you would get with regrouping. And then you're going to try these 3 subtraction problems, and you're going to have these problems on your quiz on Edmodo. I know this is a tough lesson. I still would really like you to try, do your best, and when you come into class, we can always go over answers, answer questions. If you have any questions, make sure to post them on Edmodo so we can be sure and go over them in class.